longitude and latitude. The topic longitude and latitude in this class, SS3, is not supposed to be a new topic, because according to the syllabus, the topic should start from SS2. So I'm sure you, being an SS3 student, is not a new topic to you. But in a nutshell, I would like to tell you what longitude and latitude are all about. Longitude and latitude are all about the measurements of distances around the globe. Measurement of distances around the earth. That is why you see the name given longitude and latitude. Longitude are distances that run on the globe from north to the south, while latitudes are distances that run either on the equator, which is the middle of the globe, or either the upper side of the equator or the lower side of the equator, but from east to west. So the distances that are being measured on the globe, you know that the globe is like a sphere having an egg shape. It's not actually spherical, circular. It is rather spherical. But we use the terms of a circle in most cases, because any distance that will be calculated along the globe, we say it forms an arc, and we use the formulae that are applicable to arcs and circumferences for them. So without wasting much time, let's go into solving problems that pertains to longitudes and latitudes as a topic in this class. So the first question we have says, two places, X and Y, are on the equator. The equator is the greatest circle amongst the latitudes. It is believed that the equator cuts across the earth through its center. The only line of latitude that is having a radius that is equal to the radius of the earth. Okay, but on longitudes, 67 degrees east and 123 degrees east, they are all on the same side, that is on the east. Had it been the one is on the east and the other one is on the west, there will be a different formula that will be applicable. But now that both of them are on the same side, there is also going to be a different formula that will be applicable. Don't worry, as we go through the questions we have on this topic, longitude and latitude, you understand all this. Now we are asked to calculate the distance between them measured along the equator. Assume, all this kind of a thing is very, very important. When you are given a question and there is terms that you are giving figures for, don't overlook them. If you use other standardized or other figures for those values, you will never get the answer correct. So always pay attention to all the instructions given to you in any particular question. Very, very important. So they told us that we shall assume that big R has the value of 6,400 kilometers. 2 pi R has the value of 40,000 kilometers. Log of pi has the value of 0.4971. Log of pi, not pi itself. So to do this question, in all longitude and latitude questions that may come across you, please, the first thing you must do is sketch a resemblance of the earth. It is when you sketch and put the information you have therein that will be able to get the informations and what the question is asking of you closer to yourself and easier to handle. So the first thing we do is that we are going to have a sketch that will represent the earth. I told you that the earth is spherical, having the shape of an egg. You can see that this is like an egg, but a very big one. This must be the egg of a tolo-tolo. So let's assume that this is the center of the globe. There is always a line that will run from the north through the center to the south. This is the northern part of the earth. This is the southern part. This is the eastern part. And this is the western part. Now the equator, the only line of latitude that ran from the west to the east, or from the east to the west, that has the radius equal to big radius, which is the radius of the earth. So let's take here to be the center. It is always at the center of the equator. All right. Now let's go to the question now. Two places X and Y are on the equator. They all lie on this line of latitude called the equator, which is this 0 degrees. But on longitude 67 degrees east and 123 degrees east, they were all on the east from this line toward the side. So draw one line of longitude to resemble them or to replace them. Now that means both X and Y all lie on this line of longitude. And they said that the line of longitudes, okay, sorry, but on longitudes this and this, that means X is on this first line of longitude. So that means that there are going to be two lines of longitude. Let's use this and this part of the circumference of the earth for the two. So let's assume that this is X and this place now is Y. All right. So this is 67 degrees. While this is 123 degrees. Okay? Then we are now asked to calculate the distance between them measured along the equator. The distance between here and here is what the question is asking for. Now, you can draw a line from the center of the equator or the center of the earth to those longitudes. All right. You will discover that you are going to have an angle here called tita. So if you look at this shape now, okay, let's assume that this is 0. Forget about this. You can find out that this is an arc. XY is now an arc, part of this circle, and is subtending an angle theta to the center of the globe. And what the question is asking for is the length of this arc. In our circle, length of arc is calculated from this formula. Arc length is calculated from theta all over 360 times 2 pi r. We are going to use big R now because we are talking of the radius of the equator, which is equal to the radius of this globe. Had it been is in another line of latitude, either down toward the south or up towards the north, What we're going to use here will be small r. Very, very important. But if you're measuring distances along any of the lines of longitude, their radius is always equal to the radius of the arc. So you always use big R for them. But we're going to take them, maybe that one will come maybe in the next question we're going to take. Pay attention on how we're going to get the length of arc X, Y in this question, so that you don't get confused. Okay, this is our arc length. Our theta now is, because the two places X and Y lie on the same side, on the eastern part of the globe, the way you get this angle that subtend to the center of the equator is by subtracting the smaller line of longitude from the bigger line of longitude. Had it been one of them is on the east and the other one is on the west, how you get the angle that subtend to the center of the circle is by adding their different longitudes. Very, very important. So in this case, we are going to subtract 67 from 123 to get the theta, which is this theta. So our theta is going to be 123 divided by 360. Now, that 123 minus 67. 123 minus 67. Now divided by 360 degrees. Then times 2 pi r. Remember the question says we should use this value for 2 pi r. So we are multiplying it by, or substituting 2 pi r with 40,000. All over 1. We can use our calculator now. Giving us 56. So we are going to have 56 divided by 360 times 40,000 all over 1. So we're going to multiply 56 and 40,000 and divide it by 360. The value is 6,222.22222 kilometers. So let's stop at the second decimal place. That is the length of our ink. It's drying up. So we have 6,222.22 kilometers as the length of this arc XY that is measured along the equator. And that has brought us to the end of this question. The second question we have says, two places P and Q, this should be Q, not theta, P and Q, all right, are on longitudes 152 degrees east and 171 degrees west. In this case now, one of the points is on the east, the other one is on the west. Remember the first question, both of them are on the same side. So I have picked this to show you how to calculate your theta when the points are on different directions. Okay, respectively, that means P is at 152 degrees east, while Q is at 171 degrees west. That's what I mean by respectively. Both points lie on the equator. They're all on the line of longitude that has the big R. Calculate the shortest distance between P and Q. Very, very important. Calculate the shortest distance. There is available the longest distance and the shortest distance. I'm going to calculate both of them, but we're going to pick the answer that tallies with the shortest distance as the answer to this question. As I said before, always make a sketch. Always make a sketch, a resemblance of the Earth. Make it as big as possible so that the figures you put therein will be bold and clear to your examiner. This is your north, south. Always indicate these points. It shows that you know what you're doing. Now draw the line of the equator, the only latitude that has the radius of the whole globe. All other latitudes, their R is not up to the R of the globe. Okay, so this is the sketch. Now let's go to the question. 2 points P and Q are on longitude 152 degrees east. So you're going to draw one line of longitude on the eastern part of the globe to represent P. So this point now is where our P is. And the question says it is 152 degrees. And Q is on 171 degrees west. So draw a line of longitude on the western part of the globe. And this is the point now for Q. And the question says it is 171 degrees. Okay? Both points are on the equator. Yes. Both of them are on the line of the equator. Then calculate the shortest distance between two of them, P and Q. Now, we are talking of the length of this arc that subtends an angle here that we can call theta. Arc QP is what the question is asking us to calculate the shortest distance between them. What is the meaning of shortest or longest distance? If you look at this circle, from here to here is the distance between Q and P. Also, from here through the back and back to here is also a distance between Q and P. But those two distances, as I have illustrated, we have different values. That is what the examiner or the author had always meant by saying either the shortest or the longest distance. And how do you go about it? Watch this. The length of an arc in the whole world is calculated from this formula. Theta all over 360 times 2 pi r. We are using big R because we are talking of a distance or the length of an arc found on the equator that has the radius of the Earth. This radius is big R. Alright. Now, if you want to find your theta when the points are on different directions, this one is on the east, the other one is on the west. What you do is you add their lines of longitude together. Remember in the previous question, we subtracted the smaller line of longitude from the bigger line of longitude because they were on the same direction. Even if they are on this other direction, on the west, both of them on the west, you do the same thing. You subtract the smaller line of longitude from the bigger line of longitude. But in this case, they are on different directions. One is on the east, the other one is on the west. to find your theta, or the value you substitute for theta, you have to add together their lines of longitude. And that's exactly what we want to do now. The lines of longitude are 171 and 152. So we're going to have 171 plus 152 divided by 360. Then times, remember, okay, our 2 pi r. 2 pi r has the value of 40,000. It's supposed to have been included here. I omitted it. Assume two pi r assume that 2 pi r is equal to 40,000. Sorry for that. It is part of the question. So our 2 pi r here is going to be 40,000. Make it a fraction by dividing it by 1. Now let's add, giving us 323 degrees as the value of our theta. So we're going to have 323 divided by 360, then times 40,000 all over 1. Now let me explain to you how to go about the shortest distance and the longest distance. You could find out that this theta, which you will always divide by 360 and multiply by 2 pi r, which is the length of the whole circle from where the arc is coming from, is a fraction or part of 360. It cannot be beyond 360 because the angle of the entire circle is 360. Now, any value you have here, there is a fraction that is remaining. For instance, you have 323. If you subtract 323 from 360, let's do it. 360 minus 323 is giving us 37 degrees. That means if you remove 323 from 360, you still have 37 degrees remaining. Now, the two available values of theta with which you can calculate the same distance of QP are 37 degrees and 323 degrees. These are the two available values of theta. But one of it is smaller, while the other one is bigger. If you use the bigger one, you are calculating the longest distance between Q and P. That is likely to be the distance from here through the back and back to this place. But when you are calculating, that is from our diagram, that is what is looking like. But the real distance that is longer is this one, because of the value of theta obtained by adding the lines of longitude. But from looking at the diagram, it looks as if the distance from here through the back is longer, but it's not so. So what I am driving at is this. When you are calculating the longest distance, use the bigger value of theta. When you are calculating the shortest distance, use the smaller value of theta. That is all. So had it been that this question asks for the longest value of the distance between P and Q, we'll go ahead and multiply out this and get it. Well, let's do it. This is going to give us 323 times 40,000. It's giving us this value divided by 360. We are having 35,888.8888 recorded. So let's have 89 in 2 decimal places. kilometers. This now, let me write it shorter, please, because of space, so that it will still be within the view of our camera. We have 35888.89 in 2 decimal places, kilometers. This is the longest distance. Very important. But now the question is asking for the shortest distance. That means we are going to use the smaller available value of theta. That will now give us, instead of 323, we have 37 divided by 360 times the same 40,000, which is the value of 2 pi big R all over 1. If you multiply out this, we have answered our question. Had it been they asked for the longest distance, that is where you use the bigger value of theta. And I showed you how to get the smaller and bigger value of theta. Whenever you get your theta, depending on how the question came, if the 2 points are on the same side, either on the east or on the west, subtract the smaller line of longitude from the bigger line of longitude. If they are on different directions, east and west, add their lines of longitude to get your theta. Now, when you get the theta, subtract it from 360 to get the fractions of thetas that are applicable for the value of theta for the distance to be calculated. When you use the smaller, you will get the shortest distance. When you use the bigger, you will get the longest distance. So let's now calculate the shortest distance. We have 37 times 40,000. It's giving us this value divided by 360. It's giving us 4,111.11111. So let's stop at 2 decimal places. So this is the shortest distance. So what it means now is that we have used one question to explain how to calculate longest distance and shortest distance. And that has brought us to the end of question number 2. Question number 3. Question number 3 says that X is a point on latitude 28.6 degrees north and longitude 105.7 degrees west. Y is another point on same latitude, that is latitude of 28.6 degrees north, same latitude of X, okay, but on longitude of 34.3 degrees east, different directions. One is on the west, the other one is on the east. If you want to get your theta, add the 2 longitudes. Very important. Calculate the distance xy. Assume that big R is equal to 6,370 kilometers. Just like every other question in longitude and latitude, first of all, sketch a representation of the earth and bring the information therein from where it will be you'll be closer to picking the substances you need to get your answers. So let's sketch a representation of the globe, a representation of the earth where you and I is. So this is the representation. This means that you and I, we are inside here, just this small place. That way you and myself, that way we are. Maybe you are in this point, whereas I'm in this point. As you can see that we are parallel to ourselves. All right. Indicate that this is north, south, east, and west. Very important. Your examiner will know you know what you're doing if you include all these things. draw the line of latitude. The only line of latitude, sorry, your equator, the only line of latitude that has the same radius with the globe. Now begin to bring in the information you have from the question. You said that X is a point on latitude 28.6 degrees north. That means you are going to draw a representation of a latitude on the northern part of the globe. This is 28.6 degrees north. And this should be the center of that line of latitude. And longitude 105.7 degrees. So you are going to draw another line of longitude. And this longitude is 105.7 degrees. So this point of intersection of the line of longitude and that of latitude is your X. So you can put X here. That is the first sentence. Y is on the same latitude, on this same latitude line, circle of latitude. Okay, of X, okay, the same line of latitude of X, but on longitude 34.3 degrees. So I'm going to draw a line of longitude to represent the longitude of Y. So if this longitude is 34.3 degrees, that means this place is where your Y is situated. Now calculate the distance X, Y, this arc. These two distances made this angle theta to the center of the circle. There is a relationship between this radius of this line of latitude or circle of latitude and radius of the Earth, which is the bigger radius. I want you to pay acute attention to what I want to explain now, which is the relationship between the small r and the big R. You may have been hearing your teacher saying that small r is equal to big R cosine theta. I want to prove to you from where this relationship came from. Now, if you look at this triangle, you find out that the triangle has a shape in this form. Where this place is the right angle, and this place is your theta. This place now is your theta. Now, the angle that this theta have is the angle of the line of latitude. Now, if this is an extract of this triangle here, that means this place is your R and this place is your big R. If you want to find a relationship between theta, small r, and big R, you discover that cosine is the only thing that can join them, because cosine means adjacent side divided by the hypotenuse. And this is the adjacent side, and this is the hypotenuse. So cosine theta is equal to adjacent, which is small r, all over hypotenuse, which is big R. If you make this a fraction and cross multiply, you find out that r times 1 will give you r is going to be equal to big R times cosine theta, which will give you big R cosine theta. That is where this formula, small r, is equal to big R cosine theta, originated from. It didn't come from the mercury. So when I will be using this value to substitute R. Don't assume as if I'm doing magic. No. It is from the principles of trigonometry in triangles that this relationship was created. And the explanation as an extract from your longitude and latitude is what I have just explained to you. But this is by the way. Just bear it in mind that your small r is equal to big R cosine theta. Now, we are in the business of calculating the distance x, y. Our arc length everywhere in the world is calculated from this formula theta all over 360 times 2 pi. In this case, the distance is along a line of latitude that is smaller than the circle of the globe. So the R we are going to use here is going to be big R cosine theta, which is equivalent to small r, because we're supposed to use small r here. So what I'm going to have here now is big R cosine theta all over 1. Our theta here is the angle these 2 points, x and y, makes at the center. And how do you calculate theta from 2 different points on opposite direction or on different directions? This one is on the east, this other one is on the west. The way you calculate the theta, the angle they subtend to the center of their line of latitude, is by adding the value of their longitudes. So our theta now is going to be, I want to bring this our sign of equality here so that I have enough space, because the camera is already giving me signal that I was almost exceeding my boundary. So our theta now is going to be 105.7 plus 34.3. 105.7 plus 34.3 all over 360 times our 2 all over 1. Theta is 22 all over 7 times R. Remember, the question says we should use 6,370 kilometers for R. So we're going to have, let's see, write it R cosine theta because of space. So let's add this together. I did that because of space. I was supposed to do it straight away. It's giving me 140 at dot. 140 all over 360 times, let's multiply 2 and 22 to give us 44. Let's multiply 1 and 7 to give us 7. Then we have enough space to bring in the value of our R, 6,370. 3,370 all over 1. That's the value of big R. Now pay attention to this. This other theta is not having this value. This value 140 is the theta that the arc we are calculating its length have subtended to the center of that circle of latitude. But this second theta, where you are going to find its cosine, is the theta that represents the line where you are working on. So the theta for the second space is 28.6, the value of the line or circle of latitude where the whole scenario is going on. Students used to miss it. At times they will use this same value for theta, this side, and they will begin to go down the drain from there. So what we are going to have here now is times cosine 28.6 if our space allowed us degrees. So let's multiply out now and make our expression simpler. It's giving me 239 200. 39,239,200. Then divided by 360 times 7. 2520. Remember when I told you to memorize this value when we were in the previous topics? Okay? Now cosine 28.6 is the next thing we have here. So let's find cosine 28.6. We have 0.8779 out of 1. So we're going to multiply out now. We are having 13,669.878 kilometers. That is the length of xy, or the distance of xy, as the question number 3 has required us to calculate.